How is it going over there in the West Coast? Good morning.
It's a beautiful day in the Puget Sound.
Hey, we have a beautiful day here in Houston as well, okay? Don't start with that. Now, you have the mountains, you have the falls, you have volcanoes, but you also have earthquakes and tsunamis. We don't have them here, you know? So, what's out?
Well, we are wrestling with the wettest season in recorded history here in the Pacific Northwest, and we've got lots of landslides happening. In fact, you might have heard about the one that happened in California in Big Sur on Saturday, where Route 1 was covered by over 1 million tons of rock.
Oh my gosh, that is probably what the Beat generation wanted to hear. They would like to destroy that Highway 1. So nice. Especially if you drive southward, because otherwise you don't see the sea. So, Steve, tell us about you're in Washington there, your experiences, the life of the geologist in the West Coast. But you have been living here for a long time in Houston. What are the main differences that we can say that are in between these two kinds of groups of geologists?
Well, it's all related to the position on the plates. In Houston, you're right in the middle of the North American plate. Everything is very flat and stable. And here we're right on a plate boundary. We are sitting right next to the subduction zone where one plate, the Juan de Fuca plate, is being subducted underneath the North American plate, which gives us mountains. It gives us fantastic relief and topography, and just unbelievable coastal views and cliffs. And sadly, though, along with that relief comes hazards. We have lots of natural hazards here. And so we live in a state of risk, very similar to Houston in that we have lots of flooding and other hazards and tornadoes in Houston. But here, there's a different type of risk related to geology. It's all based on where you are positioned relative to the plate.
So you mean that the geomorphology that is around us as human beings, that influence our way to be and exist? Why geologists are so much environmentalists in Washington and Oregon and California, and they are well known for their protest and their activism. And on the other side, the common thought is that in Texas it's more conservative and more related to petroleum. And why?
Well, I think it's because all geologists have an appreciation for the earth and the natural processes that are taking place. And just because you're a geologist doesn't mean that you're naturally liberal or you have a particular political bent. Many geologists who work in the oil business are very environmentally conscious. And so I see.
In fact, we are in here. We have an injection of these personalities now in the city of Houston because it's attracted so many experts that we get students and professionals that they come with a completely different mindset. Also, people that is coming from South America because of the political things, or Europe because of the economic turmoil. They arrive in here. We continue to welcome a lot of geologists, and that is why we're so international. And so I think that slightly the things in Houston, in Texas, they're changing.
Yes, very much so. But we are very much environmentally conscious here in the Pacific Northwest because there's a need to protect our environment, a great need. Otherwise, we're going to lose this natural beauty that we all appreciate.
So, Steve, what's going on? Do you have any news for us about the work, the industry, the science, the technology that is developing over there in the West Coast that is, in a sense, different than what we have here in the Petro Metro?
Well, we have quite a lot of high technology companies here. Microsoft is based here. Amazon. We have a tremendous amount of mapping capability in the Pacific Northwest, and as you know, geographic information systems is the future of really studying the planet. And Amazon is very interested in developing mapping capabilities to better distribute their products. So I think most of the technology is really centered around how most effectively to distribute information and materials around the planet. And the Pacific Northwest is right in the middle of all that. Right?
Yeah, I bet you also have, because of the configuration of the geological configuration, at least historical, a lot of mines and a lot of extraction of minerals and ores in those areas, which is in a way like is changing the society that is living in those places that have such a beautiful geomorphology, because there are these movements of the plate tectonics, and they bring up completely different minerals. Like I was talking previously about the Greek mythology. So in Greece, as I said, there are like is oceanic crust on top of the mountains, and that is probably why there are so many different mines historically. In a way, the mines of silver, gold, and iron in those mountains, they were behind the great ancient Greek civilization. That is why also they produced the first coins of silver 500 years ago.
Yeah, and even diamonds come out of volcanoes, although they're not related to the boundaries of plates.
Wait a talk. Let us see about diamonds. You say diamonds?
Yeah, diamonds come out of volcanoes.
So that you're talking about the kimberlite?
In the middle of the plates.
Leonard, tell us something, because I think we, and also here in Texas and over there, we all know about diamonds. Either you have it on your finger, or you have to buy it, or you bought it, or you're loaning some money to buy it, or you're a dog and you have it also. Something like that. Diamonds, everybody knows about diamonds. Tell us something about diamonds.
So diamond is an amazing substance. It's the hardest substance in the universe. It has exceptional qualities, the highest thermal conductivity, and all these other exceptional properties that make it very special for material science. But the source of the diamond comes from the interior of the Earth, from very deep within the Earth, where the pressures are high enough to stabilize this form of carbon. And it's only by extremely rare volcanoes that we get them transported to the surface. And then the rivers erode them, and they form alluvial deposits sometimes, like in the coast of South Africa or in Australia. But the biggest diamond deposits are in volcanoes in Australia and South Africa, and even as close as Arkansas. You can go to the Crater of Diamonds State Park.
But why diamonds are so expensive? Why diamonds are so expensive? Is it because it's difficult to dig them out?
Well, you could argue that diamonds should be expensive because they're so rare and because they're so exceptional in their properties.
But they're not.
But it turns out that there's many, many tons of diamonds that have been mined, and so that they aren't really that rare, but there's a market for them. And so De Beers has done an excellent job of establishing this cartel, the diamond cartel, that has kept the prices rather high. But I believe, because of the geological oddity of diamonds, that they should be expensive. They should be rare and demand a high price because they come from the Earth's mantle.
But?
Hundreds of miles below the surface.
But?
Yeah.
But what? But you say that there's a way of can I say speculation?
Well, there's a cartel, a market that is established, and originally it set the price. And
yeah, but it's not like cartels. So there are cartels for oil and gas, but we need that energy. But we don't need the diamond. So it really is us that we decide that that price goes up, right? So you can, listeners, that you're not geologists or that you are geologists, you can buy a sapphire or something different.
There's many gemstones that are all very rare and beautiful, and they all have very exceptional properties, but we all know that the gift of a diamond tells your true love for your special...
Okay, well, with this true love, we leave it there, Steve. We thank you very, very much. It's nice to have been out of this fishbowl, and hope to see you soon.
Thanks.
Thank you. Bye, Steve.
Have a good bye.